Good afternoon and good morning, depending on where you are around the world. And welcome to the COMIT Happy Hour here on Friday, the 25th of March at 3:30 UK time. Today, we've got an awesome setup coming along with a panel of experts from around not only the UK, but also around the world, here to look at the silver bullet, or not, as the case may be, and looking at addressing the challenges of underground utility strikes. So what I'm going to do is I'm going to hand you over to Stuart, our host today, to introduce the COMIT webinars and also the panels. Stuart, over to you.
Thanks, Ian. Okay, so thanks for joining us. As Ian said, running these webinars, we've been doing them now for the last, well, certainly 2 years on a regular basis, but 10 years prior to that. So for those new to this, what is COMIT? COMIT is a community made up of owners, contractors, solution providers, academics, and general people with an interest in our subject. COMIT has a history of developing and running projects and webinars with a focus on increasing productivity for better outcomes. Often the best improvements come from a combination of knowledge, that's the people, the process and the technology. By being collaborative with all of our stakeholders, we create value and enablement through process improvement and by setting up and delivering those all-important demonstration projects. The long-term aim in COMIT is to reduce capital project costs by up to 30% and a reduction in cycle times by up to 10%. So, on to today's session, no silver bullet. For me, and coming from a major contractor's background, delivering national infrastructure, that's lineal projects, this was the most disruptive aspect of any part of any project in over 25 years for me. It created more headaches, lost time, missed budgets, redesign, etc. But we kept everybody safe. The solution is here somewhere, be it on the screen, a combination of what we may hear from Jeff or the panel later, it's there. Somebody mentioned to me the other day that you can do this with a mobile phone, 3D real-time data capture in the field. Fabulous, let's hear it, let's see it. Just moving on, I'm sure a lot of you will have questions. Send the questions as you go. We have got a lot of questions from earlier. Some people have sent them in separately through email. We hope to ask as many as we can. If we can't ask them all, we'll try and respond separately. Okay, so I'm now going to introduce Jeff, Steve, Scotty, Richard, and Dean. So, Jeff, I'm going to hand over to you. If you want to take it away, I will bring up your first slide. Okay. Jeff, can you hear me?
Yep, I can hear you. I just can't see a slide yet.
Okay. Hang on. 1 second. There it is.
Yep, got it.
Okay.
Fantastic. Thanks very much, Stuart, for the introduction. What I'm going to talk about, no silver bullet, basically refers to the fact that this is not a simple problem to solve. That's the basic message. But what I'd like to do is I'd like to go through some of the new, this area has been attracting more venture capital, and there has been more innovations in technology affecting all aspects of this. And I thought I'd go through some of the more recent things just to give you a feel for what's going on in this sector. When you look at venture capital investment, you look at the innovation that's happening. It's really quite remarkable. Could I have the next slide? So, as I said, I want to talk about technology because it is really accelerating. In the last 2 years, it seems like every 3 months I hear from somebody, a company, or somebody, excuse me, with a new technology, and often it's technology that I had no expectation that I would ever hear. It's relating to underground infrastructure. Next slide. So one of the new technologies, and this really isn't new. This has been around for 20 years, but it's something that is now getting a lot of attention, and that is basically inertial or gyro mapping of pipes. It means basically putting I guess what often is called a pig down a pipe. These are very smart. They basically have sensors, accelerometers, and so on them. They have a battery. They don't need any external connection. They can go down 1.4, 1.25-inch pipes. They can go down 30-inch pipes. But it can map underground pipes to I think something like 500 feet, and the precision varies, of course, a bit depending on how far you are from the insertion point, but it's roughly on the order of 10 or 15 centimeters. So this is one new area. Next slide. Another one, and this is really out of left field. When this company first contacted me, said, "Well, we're thinking of using satellite imagery." I said, "How in the world are you going to use satellite imagery to map underground infrastructure?" And basically, what they have, we have 20 or 30 years worth of high resolution satellite imagery. A lot of it came from Digital Earth, but there's a number of companies providing this high resolution digital imagery. And basically what they look for is ground disturbance, indication that somebody has excavated to put in a pipeline or something like that. But it allows them to create maps of underground infrastructure anywhere in the world with fairly high precision. Next slide. This is something that's very new. We just had a conference relating to underground infrastructure a couple of days ago, and there are two companies that announced something there. Basically, the first announcement of this technology, which is just on the verge of being commercialized. This is using a drone to find underground infrastructure. People have thought about this and talked about it for quite some time, usually thinking about putting ground penetrating radar on a drone. And if you know anything about radar, you know that's just not going to work because you're not going to get any penetration. But putting a magnetometer on a drone is another matter. And this is a company called Skipper NDT, which has done that. They've been working with the French National Research Agency to prove the technology, and it is now on the verge of being commercialized. So this is brand new technology that could dramatically change how we detect and map underground infrastructure. Next slide. This is also a very novel one. This was just announced at the conference a couple of days ago. Real-time damage prevention. This doesn't require any external data. Basically, it's a modified bucket for a backhoe, which has ground penetrating radar in it. The interesting thing about this is that it's really not subject to some of the constraints of GPR because it only has to go down a foot or two. You're only scanning the area where your bucket is going to dig next. So it basically makes it possible to scan where you're going to dig before you dig, immediately before you dig. And if the scan detects anything under there, you get that warning where you can see utility detected. I mean, this is really quite remarkable. And like I said, this was just announced. This is the company has been working on this technology and proving the technology, and they're just on the verge of releasing it to customers for alpha testing. Next slide. This is something that is being done at the University of Birmingham in the UK. You may have heard about it, quantum gravimetry. You've probably heard of gravimetry before, and it's a very slow, tedious process, not very accurate. But when you start using quantum effects to enhance the sensitivity and the speed of this, it really becomes something significant. This is still really in the academic world, but I think it's just on the verge of being commercialized or being put in a context of a commercial environment rather than just a academic environment. Next slide. This is something also that is very new. This is just being commercialized, but basically using deep learning computer vision to automate recognition of facilities. You know, when you do an inventory of poles or any kind of utility equipment, it usually involves going out with a clipboard and a piece of paper and writing things down, or else a handheld and writing things down. And the amount of time you have to spend on each device is really substantial. And this is the first time I've seen basically using these, basically using deep learning and computer vision to automate that process, so that you automate the process of recognizing the device, capturing attributes about the device, capturing the location of the device. It's not at the stage of fully automated right now. It's still semi-automatic. There may be questions that the operator has to respond to, but it is really speeding up the process of capturing information. And if you know anything about utilities, they often have a backlog for updates to their as-built or to the records or to their to the information they have about their network information. And this, I think, could really dramatically change that. You could imagine a worker just going out with a hard hat, having a camera on it, and not having to write anything down. The camera recognizing everything, capturing all the information that's required without the worker actually having to do anything. Next slide. And this is what I think you've probably heard about, heard quite a lot about, and that is basically using a smartphone. Nowadays, you need to have, if you really want high accuracy, centimeter accuracy, you need to have RTK or a base station or some accurately surveyed control points. But this can give you centimeter accuracy with a smartphone in the field. And this means that you can have a construction crew actually capturing the location of newly installed infrastructure. You don't have to have a survey crew. You don't have to call a survey crew and wait for them to arrive and do the survey and so on. The surveyors are still involved. In other words, any of the data that's captured is still reviewed by them and may have to be stamped by them and whatever. So it's definitely not taking surveyors out of the picture. It just is just making the capture much more efficient. And not only can it be used for newly installed infrastructure, but can also be used for utilities that are exposed, during a SU survey or whatever. Next slide. And I think from the point of view of being able to capture and share this information, there are a number of companies who are doing this. I just call it mobile plus cloud, because it usually involves a mobile device capturing something, uploading it to the cloud, or downloading information from the cloud that can be, that is being shared to anybody with a handheld device. This is definitely being used in Colorado right now, and the source of the data is, or the data that's actually captured is a source of information for high accuracy as-built. It's used to capture information for SU surveys. But basically, it means you can capture high accuracy information and share it within minutes with everybody who's involved, whether you're talking about contractors, network operators, engineers, or what have you. Next slide. And I think probably as a result of some of this technology, and also, just the fact that a lot of cities and even countries like UK, for example, are interested in digital twins, people are talking about subsurface digital twins. There are companies, for example, a company called Reveal that did a subsurface digital twin for Wellington, where they had a disaster a number of years ago, so they really had to relocate and redefine all their underground networks. So it's actually a very good place to do that. In general, a subsurface digital twin not only includes infrastructure, but also includes the geology. I think most people who, even if you're involved in, if you do any ground penetrating radar, you know that knowing soil conditions is really critical for determining how much penetration you're going to get. The other aspect of subsurface is that it's got some significant differences with above surface digital twins. Above surface digital twins, basically anything that you can photograph is valid, whether you're using a satellite, an airplane, ground-based, or whatever. Anything you can photograph can be legitimately shared. But underground is different. First of all, a lot of the underground data is actually owned by private companies, and that means they own, they own the infrastructure and they own the data about it, and so that is an accessibility problem. And another key problem is data quality. Like I said, it's often utilities and telecoms that have the data about the underground, but there have been, for a variety of reasons, the quality of that data is often substandard and is not of the appropriate data quality you need for a digital twin. And the other part of it is fitness for purpose. There's a whole bunch of things you can do with underground data, not only just worrying about damage during excavation. It can be used for emergency services. It can be used for a number of applications. And if you've got an application, if you're interested in emergency services, for example, or disaster planning, you may not need the precision that you need if you're using it for excavation, for preventing damage during excavation. Next slide. So one thing I'll just touch on briefly is evolving standards. When you have technology changing rapidly, like it is, and when it comes to underground, it means that standards have to evolve as well. And the good news is that I think the standards are doing that. Next slide, please. You can look at standards. This is basically a list of all the standards that I'm aware of, starting with 1983, as I mentioned before, with Japan. It's really not. It's sort of a standard for Tokyo. It's not the standard in the same sense that the ASCE 3802 in the United States, which is basically the grandfather of almost all standards. That was issued in 2002. But Malaysia, Canada, France, Australia, UK, Ecuador, there's a number of countries around the world who have developed standards. And the PAS 128 in the UK in 2014 was really important in basically allowing you to assign different quality levels to underground infrastructure. It has a similar structure to the ASCE 3802 in the US, but it has some significant differences, and it has been revised in 2021. And I'd say the most important difference is that whereas the ASCE 3802 didn't refer to any absolute accuracy or precision, PAS 128 does. Next slide. Now I'm going to talk about how this information is captured and shared. Next slide, please. Over the last 25 years, I have visited a lot of parts of the world, and every time I went to a new city or wherever, I would usually ask them, say, well, what are you doing about underground? And it was remarkable how many different places were doing things. They were always using a different mechanism as far as governance. And this is just a list of some of them, just to give you some idea that there's not only one way of doing this. There's a number of ways of doing that. So in some cases, it's a government mandate. That would be, for example, in Flanders in the Netherlands, the DT-DIC system in France, the federally regulated pipelines in the US, the Colorado Department of Transportation, and so on. There's some other ones as well. There's government voluntary, and the classic example is the Vault in Scotland. In some cases, it's an NGO consortium. The ICI Society in British Columbia, which has a lot of underground infrastructure data, location, and so on, as well as tax boundaries and so on. That is not something that government is involved, but not heavily involved. They're not running it. They participate because they're involved with tax boundaries and something like that. I know Pernambuco in Brazil, and I would probably include DigDat in the UK, Anglian Water, as an example, where just some folks, often utilities and telecoms, just say, this is ridiculous what we're doing right now. Why don't we get together and try to share data? In the US and Canada, there's a mandated industrial, and it basically is a mandated consortium. It's called a one-call center. It's not funded by government. It's funded by the utilities and telecoms, but it's mandated. There's legislation that requires that utilities and telecoms participate and require that contractors call one call before they dig. In some places, it's basically a regulation. There's usually enabling legislation somewhat, but a lot of the details are actually regulations, and that would include Colorado, Montana. There's some really interesting regulations from Ofwat in England and Wales, Las Vegas, and a few other places I could name. In some cases, an industry association. We've already talked about the Common Ground Alliance in North America, which is remarkable because it's basically collected a lot of data about underground damage, and is a source of a tremendous amount of assistance when people are designing solutions to this underground problem. In the UK, there's the Utility Strike Avoidance Group, the USAG group, which is attempting to do something very similar to the Common Ground Alliance. Then there's private for-profit organizations that do something similar to a one-call system. Line Search Before You Dig, you're going to hear from Richard Broom later, and some other ones. Pelican Corp, which I think is involved with Line Search Before You Dig, but also has implementations of one-call systems in Australia, US, UK, Singapore, and Canada. In some cases, it's contractual. In other words, it's not mandated by government. It's just written into contracts. And Singapore is an example of that. Basically, if you do any work for Singapore that involves surveying, locating things, it is contractual in the agreements from the Single Land Authority or the other government authorities that there's certain. It has to be done by a certified surveyor. Certain equipment has to be used for it, and so on. And then, of course, there's airports, universities, ports, hospitals, and so on, industrial campuses that are often privately owned that have implemented their own systems for doing this. So anyhow, the main point I'm trying to make here is that there's a lot of ways of dealing with this issue of how are you going to share this information. Next slide. One of the things that I think is really essential and is not probably recognized how important it is, and that is collecting information about damage to underground infrastructure and compiling that information and publishing statistics about it. And I want to give you some examples around the world of where this has actually happened. Next slide. We've talked about the Common Ground Alliance, which is an organization. It's basically an industry organization. It's not government. It's not paid for by government. It's not mandated by government. But it's basically the industry getting together and say, we really need better statistics about underground damage. And it's not mandatory to submit incidences of underground damage to the Common Ground Alliance. It's totally voluntary, but it's remarkable how much data they get. I think it's something on the order of 400,000 submissions every year. The estimate of the total number of underground incidences in the United States is something on the order of 500,000. Some people think it could be almost twice that. So somewhere, the error bars that the Common Ground Alliance have shown at various times is between 500,000, 800,000. So it's almost like one every minute or two every minute. It's incredible how much damage goes on, but it's really important to have this kind of data. And one of the things that the CGA tries to do is to be able to compare different years. And the way they do that is they look at what they call consistently reporting sources. That means sources of damage reports where they have been doing this for a number of years. They just haven't done it 1 year and decide the next year they aren't going to do it. They have been consistently reporting damages for a number of years. And when they look at that and they prorate it to the construction activity using basically millions of dollars of construction spending, what they find is that ratio, which is, you can think of it as the number of damages per construction million or per construction dollar per $1 million of construction. That ratio has been constant and slowly increasing for the last 5 or 6 years. So it really shows that the one call system in the US is not really reducing damage. I guess the best thing you could say about it is that it's preventing it from getting worse. Next slide. This is a Ontario Regional Common Ground. It's part of the Common Ground Alliance, but it's specifically to Ontario. And they do a lot of the same things that the Common Ground Alliance does. They also collect statistics. Instead of trying to prorate it to $1 million of construction activity, they prorate it to the number of notifications. The notifications are when the one call center receives a request, then it notifies all the utilities and telecoms that have equipment in the area of the proposed excavation, and that's called a notification. And so what the ORCGA reports is the amount of damage per 1,000 one call notifications. And similar to the CGA report, the DIRT report we just talked about, it's basically constant. It goes up and down slightly, but it's basically been constant for probably about the last 6 or 7 years. So again, the one call system in Ontario is not reducing damage. It's, as I said, the best thing we could probably say about it is that it's preventing more damage. Next slide. This is a one call system in the Netherlands. It's different from North America in that when you call the one call system in North America, they don't send you pieces of paper or digital maps or whatever. A team, each utility and telecom sends out a truck with a team with electromagnetic and ground penetrating radar to try to find out what's underground. And that's because they recognize that the as-built records are unreliable. And in the Netherlands, different. When you call, it's called click online. You can do it all online. You go in to find this a polygon saying this is where I'm planning to have an excavation. And usually within 24 hours, you'll have all the maps, digital, whatever, that relate to all the infrastructure underground, whether it's electric, gas, or whatever, as I said, within 24 hours. Which is, from a business efficiency point of view, is really fantastic. The bad news is that, they're using as-builts, and as-builts, as we know from just about anywhere in the world, can be unreliable. So that this is a significantly different system from the one call system that we have in North America. But they also published it, the cadastre in the Netherlands. And the telecom agency there publish annual statistics. I've got some here from 2016 through 2020, and you can see the blue bars is basically the number of notifications. The red line is the number of damages, and the numbers in red circles is basically the ratio between that. So you can think of damages per notification, and you can see again it's basically flat. It's not going up or down. It's definitely not significantly changing, reducing the amount of damage. And again, I'd say, well, maybe it's saying that what we're getting the message here is that at least we're keeping a cap on it. It's not getting worse. Next slide. And this is the French system, and we just heard a talk 2 days ago from somebody in France describing how this actually works. I won't get into the details, but basically what the objective of the system is that you don't do any construction, planning, design, excavation until you know the location of all underground infrastructure to within 40 centimeters. And if you contact all the utilities and telecoms that have equipment where you're planning to dig, and some of them will have data accurate to 40 centimeters, some won't. And for those that won't, then you actually have to have a locate contractor or a locate professional to go out and find where things are to 40 centimeters. And there's rules for how that's paid for. And I won't go through them, but it could be paid for totally by the contractor. It could be paid for totally by the network operator, or it could be 50-50. It all depends on what it depends on the quality of the data. When you start to locate. The other thing about the French DT-DIC system again is that it's mandatory reporting of damage incidents. Like I said, this is one of the really critical things. If you don't collect data, it's hard to say what you've implemented is actually doing something. And I've shown you the statistics. Again, it's a ratio. It's basically statistics per notifications again, and they express it as a percentage. But back in 2013, when the DT-DIC system was first implemented, that ratio was about 0.42. In the most recent report, annual report, it was down to 0.26. So this is an example where there's a system that actually seems to be reducing damage, and that's why I think it's really important to collect statistics and to be able to report on those statistics to see whether to see what you're doing in trying to reduce damage is actually working. Next slide. So just getting back to the main theme of this talk, no silver bullet. Next slide, please. Some people will say, well, underground infrastructure, this seems to be a problem all over the world. There's probably not much we can do about it. We can just try to tweak the existing systems to make things better. I want to just give you some statistics comparing U.S. number of incidents in the U.S. annually and the number of incidents in Japan. This is for 2016, the only year I have Japanese data for. So in the United States, at that year, it was something like 309,000, like 390,000. Now it would be closer to 500,000 incidents, somewhere between 500,000, 800,000 incidents annually of underground damage. And in Japan in 2016, for comparison, it was 134. And I haven't left off zeros here or anything. I mean, it literally it was 134 in 2016. So it shows you that, what I'm trying to show you here is that you can do something about it. But I think the key is that there's no silver bullet. Next slide, please. Next slide, please. So let me just give you an example close to home. Heathrow International Airport. That's a map of the underground stuff in Heathrow. I mean, it's probably one of the densest underground areas of underground infrastructure in the world. It's probably even denser than Tokyo. And the statistics are incredible. I mean, the number of different utilities that are underground in Heathrow. There's 50 different network owners. Thousands of contractors are working on various aspects of Heathrow at any given time. Next slide. And so in Heathrow, if anybody hit something underground, it would be a real big problem. And so I've just outlined some of the things that the Heathrow has done to reduce the underground damage. It is not simple. It's not, just use this cool technology and you won't have a problem, or just implement this procedure and you won't have a problem. So at Heathrow, there's a mandatory 7-step process going all the way from preliminary design through closeout that a contractor has to follow. It includes things like safe digging, which means exclusion zones based on the PAS 128 quality level that's assigned to each piece of equipment. Often involves hydraulic, vacuum, or other equipment. It may be that you have to use hand tools. There's a variety of rules of what you can do depending on how close you are to a utility. Another really important thing, which I've referred to a number of things, is mandatory reporting of underground strikes. This is really key. If you don't know what's going on, you can implement all sorts of wonderful things that look great on paper, but may not have any effect whatsoever. And the other thing that I should mention relating to Heathrow is that they have strict requirements for training and certification, so that all people involved in doing contract work and specifically involved in detecting and mapping underground infrastructure have to meet those standards. Next slide. And these are some statistics. This is fairly old stuff, but the important thing is that if you follow those rules and regulations that are required at Heathrow, you can see the green line is construction activity, which has increased significantly over this period of time, and you can see that the yellow line, which represents damage, has decreased at the same time. So this is an example where you can implement a number of messages, basically a comprehensive program of measures to reduce damage, and you can actually see a change. And I could show you something similar for Japan because it's basically the same thing. Next slide. So I think the key takeaway for what's going on right now, first of all, there is a lot of technical innovation, which is changing how people do things when it comes to underground infrastructure. Secondly, there's many different ways to address the problem of how you capture and share this information. It ranges all the way from government mandates to just to NGO organization, industry organization. There's a lot of different ways to do this, and different jurisdictions have used it. One thing I really want to emphasize is that probably one of the most important things you can do is collect data on underground damage and compile and publish statistics, whether it's annually, weekly, or monthly, some way of getting some feedback about whatever measures you're undertaking that you can see whether it's effective or not. And then finally, the Heathrow experience, the Japanese experience, and a few other places is the what that shows is that there's no silver bullet for this. It's not like you can just say this cool technology, this cool governance measure, this cool organizational structure is going to solve the problem. You really need to have a comprehensive approach to this, and it has to involve contractors, it has to involve network operators, it has to involve government, it's got to involve the locate industry. In other words, all the stakeholders in construction have to participate in that. Next slide. So I just want to thank you for listening. This is some contact information for you if you want to get in touch with me. Again, thank you very much for listening.
Thanks, Jeff. That was superb. The last one we did, which was just about 19 months ago, I was just saying at the beginning, it ran through the extra time, it ran into the next half hour, and then it ran for 6 months with the discussion that we had. Hopefully a few things have come from that, and it was great to have you back. We've had a lot of emails in between posting this through social media and through the usual channels, and it was great to see the advances that's been made in the time in between. So thanks for sharing all the information. What I will say is we have some poll questions. Now, we deliberately left them to the end. Maybe we'd get some different answers than we would have done it if we'd sent them at the beginning, but I'm just gonna move on to those now, actually, and launch them if I can. We have some questions that have come in as well, but I think before I do anything else, I will throw the first question on the screen. So, recent tech advances in detecting and sharing underground information is going to change how we detect, capture, and share information in the future. Okay, you should be able to see that. You should be able to see that now. Do you strongly agree, neutral, disagree, strongly disagree?
I don't think they can see the poll yet, can they?
No, I'm not sure you can see that. Can you see that?
Yeah, I can see it.
Okay, yeah, no, there's people responding. Thank you.
It's not coming through at this end.
It's not on my screen. It
It's
is now.
I can see it, Stuart.
Yeah, it's there now. Okay. Just give that a couple more seconds. Good portion have voted. Anybody left? No. I'm going to close that and I'm going to share it. So at this point, any of the panel members can come in and comment. Can you see that now? 25% strongly agree, 53% agree, 22% neutral.
What's quite interesting is that nobody disagrees at the moment, or nobody has an opinion that it is wrong, if you sort of mean. They could be unsure, but they're not saying definitely not, which is really as it should be. It's costing the economy a massive amount of money.
Anybody else want to jump in and comment? Dean, this is right up your street.
Yeah, I was getting quite familiar with what Jeff was saying about the augmented reality and gathering data. My background is in utility avoidance training, so I trained thousands of guys since I started doing this job. And one thing I always kind of notice is you see lots of spray marks on the floor of where these engineers go out and the utility surveyors go out, but no one's actually recording it as they're spraying it or when they expose the utilities. So there's a great opportunity, I think, for the ground workers also to get involved in this kind of thing. They're at the forefront. They're physically, quite literally, sometimes standing on top of where these utilities are on the ground, and that would be an absolute fantastic opportunity then to use the technology to go out and gather the position of where these utilities are before they backfill those trenches. And we're working with or just about to start working with a Canadian company called VGIS that are part of the Hexagon group to try and democratize the whole utility mapping sector, just to see if we can put it into the hands of these guys who also break the ground. So yeah, I totally agree. It's only going to be a good thing. The more information we gather, the more reliable the information we gather, then the easier it is always going to be to identify, locate where the position of where these utilities are to increase safety. I mean, my main ambition is to increase the safety of the guys who are actually excavating. So the more we can do that, the better.
Yeah, great. Well, thank you for that. Thank you for that. I'm going to launch the next question now. Is the current status of underground data up to the standards required for a subsurface digital twin? Should be able to see that on your screens now.
Oh, wow. As people are answering that one, I mean, I'm currently looking at the, I suppose there's a circuit board that helps to understand the connections between all the different sectors within various organizations across the various bits of infrastructure. And I've got to say the connections between them, even not knowing exactly where the connections are, the actual connection itself is not clear. When you ask some of the infrastructure providers and the owners, getting that data in the first place is like pulling teeth. And even getting the data to know that this thing connects to this thing, not actually where it connects or how it connects, but the fact that it actually connects in the first place is hard enough. So I'm really interested in this question and see what people think.
Okay, I think everybody's voted now. Let me close that and share it.
Oh yeah. I would heartily agree with that. No, at the moment I'm using high resolution satellite imagery to look at the connections between various transportation, communications, water, power, and medical networks on an island. And really, it's impossible to be 100% sure that even this facility connects to that facility, let alone where it is in the ground. So yeah, we can only hope.
Anybody else want to comment on that?
I would add that this is Scotty, by the way. It certainly seems like the answer was a lot in the presentation, and that a lot of the new technologies are focused on gathering data at this time.
Yeah.
So.
Okay, thank you for that.
Just on that, Scotty, gathering data, yeah, that's great. But whether I missed this in the presentation, is there a standard, whether it's a UK or an international one, of how we actually record it? Is it X, Y, Z coordinates? Is it longitude, latitude? Is it, how do we, I'm just thinking, when I take one set of data from an infrastructure provider and the data from another infrastructure provider and try and bring them together, because they're all in different units, they're in different ways of measuring, different tolerances, sometimes it's absolutely impossible to bring that data together without a hell of a lot of hard work. Any thoughts on that one?
I'm not aware of a regulatory standard, but I mean, in terms of technology that we provide at Reconstruct, we create a 3D space where you can unite all forms of data, whether it be aerial imagery, CAD or BIM models of any kind, and then reality capture data, so that you can bring them together in a 3D space or overlaid with geospace.
So if there isn't currently, from what I'm hearing here, if there isn't currently a standard of not just that we have to record it, but how we have to record it, if there isn't currently a standard of how we have to record it, is that not, do you think, potentially a good starting point? Potentially.
It certainly seems like a good starting point, and with the need to record statistics and publish them, it seems to be we're gathering evidence to create a standard.
Brilliant.
Going to launch the next question.
Sorry, Stuart, just to cross here. Ian mentioned about what standard is required. Jeff put in his slide there, PAS 256, which is basically should be the standard for recording that information. That should be going back to the asset owners.
Yeah, but I don't think it's, it doesn't require a certain format or certain, I think the closest thing to what you're talking about is an initiative of the Open Geospatial Consortium called MUDDI. And that is designed to set a standard for the exchange of underground information, which I think is what you were talking about.
Definitely, because if there isn't a common way of doing it, no matter whatever technology we have, no matter how good our intentions are, when we try and bring all those multiple sectors of buried services, whether it's gas, water, communications, whatever that might be, together, we're going to have one hell of a headache. I mean, we've got those problems now just bringing together CAD data on the surface. But if we start, if we haven't started recording it completely now, and we're going to start recording it in the future, if we set that standard now, how much further forward are we?
Yeah, exactly. And I think, basically MUDD, the MUDDI or MUDDI standard, the objective is to create a common data model for the exchange of gas, electric, water, everything, right?
Brilliant.
Yeah.
That is fantastic. Sorry, I kidnapped that conversation. Stuart, back to you.
That's all right. I've got the final poll question, if you wouldn't mind. It involves technology. Should be able to see that on your screen now. What do you see as the next important underground utility detection technology? And Jeff talked about most of them there.
Stuart, I think I've certainly got the results slide.
Still got the results slide.
Oh yeah, I'm not understanding why it's doing that. Just bear with me a second. Can you see it now?
That's the same one, I think.
So the results. So pressing that pull down, can we pull down that? Okay, for some reason it's not moving forward. So your choices are, now I want you to all to have a think about this, perhaps put it in the chat window, whether it's A, B, C or D. Firstly is improvements in capture and analytics for GPR. Secondly, underground locating with a drone. Thirdly, real-time damage avoidance with specifically, what does that say, Stuart? You're going to have to expand that window. My apologies, chaps. With specific, especially equipment,
excavation equipment.
Excavation equipment, and then finally the option D, quantum gravimeter.
Gravimeter. Yeah.
Wow, I'm going to have to Google that.
Jeff had explained it earlier.
Ah, I apologize. I was getting really excited about what Jeff was saying earlier.
Sorry, guys. That's for some reason that poll isn't working. No. It's not working. Yeah, sorry about that. We'll skip on. We'll skip on. Thanks for everybody that gave us their answers in those poll questions. Okay, so one of the things I want to do is let me just skip through the next slide. I want to just bear with me a second. I'm going to have to just bear with me.
Oh, that'll be my fault, Stuart. I'm an absolute Jonah for technology, so I probably messed that up. There we go.
Okay, so let's get to question time now. We've a whole host of questions, and if I may, I'll just start with what we've got on the floor. Oh yeah, we've got a whole bunch of questions coming. Right. I'm going to start with the question, is it Fiona? Fiona. Jeff's Heathrow example is interesting. Heathrow has the benefit of a large fence around it and strict procedures in place for those who are allowed to work there. Does this suggest the emphasis in utility strike avoidance should be focused more, let me see if I can read this, more strongly on human behavior? Jeff, can I give that one to you?
Well, the point I'm trying to make is that I think you need everything. I think you need a comprehensive approach, and that's what Heathrow did. You're absolutely right. It has a fence around it and all that kind of thing, but I'm not sure that that is the most important thing. I think it's just that they've enforced certain processes, and the processes involves contractors, network operators, government agencies, which responsible for running Heathrow, probably locate industry and so on. You can't just take one. I guess my point is you can't just take one stakeholder group like contractors and say it's all your responsibility. If you can just clean up your act, we wouldn't have this problem. Or going to network operators and say, well, if you just get your data so it was reliable and we could read it and it was accurate, then we'd solve the problem. I think the message is you need everybody involved in this.
Hi, Jeff. Can you hear me?
Yep, I can hear you.
Yeah, sorry, we lost the audio there for a second. Could you repeat that? I'm sorry to ask.
Okay.
Again.
Yeah. Can you hear me now?
Yes, loud and clear. Yeah.
Yeah. Okay. So the point I was trying to make is that you're absolutely right. Heathrow has a fence around it, and there's rules and regulations and things you have to do within it. But what I'm suggesting is that it's not so much the fence, it's the rules and regulations, and the fact that those rules and regulations involve contractors, network operators, government agencies, the Heathrow, Airport Authority, locate industry, people who, the people who do the vacuum and hydraulic excavation. I think the point is that you need to have everybody involved in reducing underground damage. You can't just go to the contractors and say, for example, just go to the contractor and say, well, if you guys would start being more careful when you dig, the problem would go away. Or going to the network operator and say, well, if you'd clean up your as-built so that they're reliable and accurate, the problem would go away. I think the point is that you need to have everybody involved in the solution.
Sure. Okay. Thank you, Jeff. I'm just trying to get the next question up.
Well, I've got one for Scotty here. It's come in. How can we use reality modeling to improve the documentation of A, existing underground utilities, and B, the documentation processes during the installation of underground utilities? I think that was probably a pretty good question. Scotty, over to you.
For sure. Thankfully, Jeff covered a number of different technologies that are available today, such as, drone footage, but also capturing with a simple, 360 camera, or even just your smartphone. The ability to, whip out your personal device or just a phone you have in your pocket when you're doing work definitely enables a lot more capture of any exposure, during excavation progress or during installation progress. That simply, hasn't been happening to date. But it also allows you to capture any exposure, plot it, geospatially, and then as you're building, as you're leveraging as-built, as you're leveraging any other type of data that can be plotted in 3D or geospatially, you can unite all of that data together to fill in a model of where all the underground utilities are.
Yeah. Okay. Thank you. I've got another one here. Wanted to just ask Dean. Now, you talked a little bit earlier on about training people in that sort of environment. Do you find there's a large intake in contractors and owner-operators on training people for this issue? Do you find people are taking it seriously enough to put a lot of people on training courses, or are you finding it more of a tick box type exercise by those employers?
It would unfortunately be the latter. Most in the past, you have companies who do take it seriously, such as Heathrow. I mean, they have very strict guidelines on the procedures and who works in there. But because of the other piece of guidance, we've got the HSG 47, which stipulates all people need to be trained on locating devices before they use it. It can be more of a tick box exercise. But what I have found in recent years is companies and end users, self-employed or employed, large or small, are utilising plans and drawings a lot more than what they used to, which is great, and it's fantastic. But we need to make sure that they're utilising them correctly and they're accessible to them. So the uptake is always going to be there for training, and as new equipment comes out, it will only increase. It's never going to decrease. But we just need to make the technology and the information more accessible to them. If we make it more difficult or more unreliable, then you tend to find they get turned off and then just go back to their complacent old ways. So, but it is good news that it's a massive increase in companies actually utilising line search. Yeah, with Richard Broom, they're actually utilising it now. We encourage them to use it every single time. We give them the links for it. It's that to me is a standout point over the past, I'd say, 3 or 4 years. That has massively increased, which is a good sign.
Yeah. Can I just add to that, please, from a contractor's perspective? Couple of things for me is we certainly stipulate very heavily the need to have, in essence, as a minimum, the EUSR utility excavations training, certainly modules 1 and 2. We have, and certainly personally, been involved with supporting and updating the content for that training course. So we do heavily support the need to have training, absolutely. It is a minimum standard that EUSR provides, which gives you the option for certainly I think for certainly the main contractors to add with their own systems and terminology, so that they fully have got resources out there that actually do understand what the training is, what the issues are, what the hazards are, and they train with the appropriate equipment. So certainly in terms of the contractor fraternity, hopefully on the line, I would think that we are certainly fully embracing the need to have trained personnel on site with the appropriate equipment that's fully calibrated and they're familiar with, to be honest, because we are certainly, in terms of safety and excavations and saving lives, it's one of our key priorities, to be honest, on that one. I know that Dean mentioned about HSG 47, which I think is a real document out there that's been out there for a number of years now, edition 3, of which it is a key, I think, guidance document that we should all, I think, revisit, to be honest, not just the contractors, but also it has responsibilities, I think, also for the asset owners as well, in terms of some of the things they should be doing, to be honest. So there's, it's a big area. We can be talking all day about this, Stuart, so apologies for intervening.
That's all right.
That's really good to hear, because I mean, I work for I'm not going to mention their name, I work for a house builder, as it were, a developer back probably 25, almost 30 years ago now. And literally when we recorded the utilities going in the ground, I would just offset the curb line in the CAD drawing, and that became the water, and then I'd offset it a little bit further and it became the power, and I'd offset it a little bit further again. And quite frankly, I look back at that now and think it was absolutely shocking, but it was standard practice at that moment in time. And it's so nice to hear that it's really being taken seriously in this context now.
It has to be, Ian, because that curb line now doesn't exist. So how do we now re-excavate to find safely where these utilities that you put in the ground are marked apart? Yeah, to be honest. So there is a need for that standardisation, absolutely, and discipline.
There's a comment here from Paul. Thanks, Paul, for this. We absolutely need a mandated standard for capturing data. Thanks for that, Paul. I've got a question that came from Andrew. To what extent do you think that service strikes occur because of poor detection techniques through existing methods? I think we touched on this, a little bit of this earlier. E.g., no use of Jenny, no direct connection to street furniture, use of sondes, etc. Anybody want to take that one? Jeff, do you want to take that one?
Well, I think if you look at what's happening in some jurisdictions around the world, I think people recognize, and there was a Common Ground Alliance study a little while ago, and I think also Line Search had a study that said the quality of underground infrastructure data is a major problem. And I'm sure Richard Broom can elaborate on that from the report that Ellis Budd did.
Thanks, Jeff. Not sure which one you mean on that one, but I think it's interesting when you had that poll question about what's the best or the best advancement in utility detection. I'm looking at Dean on the sort of fixed screen there, as Dean does this every day. You know, he uses the best technology available to train people up. But I think for me and the experience from the strike avoidance team at USAG is still too many examples of people not using the cat or the Jenny, the cat on its own or not at all. And so I actually think there should be another answer to that question, which was there should be better use of existing technology, because I think whilst there's some amazing stuff going on out there, if you can get more people to use what's available now consistently, then I think that would be a really big win for the industry. But Dean's the expert in this one, not me really.
Dean,
I don't believe there are poor users of this equipment. I don't believe that there are poor trainers either. I just think people are being ill-advised on the correct application of using the equipment specific for the job that they're doing. So when we try to say go on a hashtag Cat and Jenny course, it could be a little too generic. So we need to tailor the training to what they do. So we try to do that as best as we can, but obviously we're governed by guidelines from the USR and the CITB and the whatnot. But it is totally true. If they use the kit correctly, then they will reduce the chances of hitting utilities. But we've also got to understand there's got to be a lot of onus responsibility on the asset owners putting utilities in the ground which aren't detectable by a cat or a Jenny. But they could be quite simply. Where I live in Stoke-on-Trent, Staffordshire, they're putting kilometres and kilometres and kilometres of new fibre optic infrastructure in the ground, and they're just chucking detecting tape in the ground, and it doesn't work by just putting it in the ground. It has to be installed correctly. I did work in the Nordics. Over there a few years ago, you can connect to one cable coming out of the ground, and it'll light up the whole fibre optic network like Blackpool illuminations. It isn't difficult to do that here. We can go on about people not using the Jenny or the cat or both together for forever and ever, but the fact is there's more stuff going in the ground that the cat and Jenny can't find anymore.
Yeah.
So this is why we're trying to, it's not simplify, but make accessible more advanced technology such as GPR. The GPR is not difficult to use. It's very simple to use. It's the analyzing the data, which can be quite tricky. So we're trying to simplify that, make people be able to use it correctly. But there has to be an onus on the asset owners as well to make the cat and Jenny better to be used by making their utilities detectable.
Yeah, indeed. There's a comment from Paul. Thanks for coming back, Paul. There's a lack of understanding of PAS 128 by excavation teams. There needs to be a better understanding by the teams for this. Thanks for that, Paul. Okay, so just go on.
Quick question on that, Paul.
Okay.
Do you think that is a problem on how the PAS is written, or potentially how the PAS is trained or put across? Because some of the PASs, I'm in the sort of the digital world, the BIM and the digital twin world. Some of the PASs and the ISOs written are absolutely incomprehensible to the normal human being because they're written by academics. So the question here is that just pop it in the just for my own interest, Paul, pop it in the chat window there. Do you think it's because the PAS is badly written, or do you think it's just not being trained properly?
I'll ask him. Paul, we can bring you in if you want.
Because I think, a lot of the problems we have in our industry is because we have, I think a lot of the documentation we write is just not fit for purpose. Paul, so I think you might be able to speak now. Are you there?
Oh, yep. Can you hear me now?
Yep. Good.
Yeah, I just think when excavation teams go out on site, they've maybe not been shown what the easier side of PAS 128, like the basic sort of rules behind the actual table. Because if you put the table up on the screen and show what PAS 128 is all about, really, it's quite simple to understand. And probably they don't get to see that table, don't get explained to them that a B4 line is, it's not where it actually says it is, and that's the thing that we need to get across to the teams excavating. If you go out, someone goes out and does a PAS 128 survey for them, we do that on our HS2 project. We've got all this great PAS 128 data, but when we push it back down on the ground again, if you've got a B4 line, that's taken from records, and every line that they see on the ground, more than likely they're thinking that's exactly where it is, and that's their mindset. They think that's exactly where it is.
So
and we've got a team of survey. I know we can't have this across the whole board, but we've got a team of survey avoidance teams and utility surveyors that go out, mark that up, and during the briefing, they get briefed out to the team what those lines all mean. So they're not just going to think the lines directly where, it's directly above the cable. I don't have to worry about that. They're above a better understanding of it. So, we're lucky at HS2 that we can afford to bring those teams in. I know that not everyone can do that. However, we do have survey companies going out and doing these PAS 128 surveys and markups for our subcontractors on a regular basis. But they don't necessarily go out and brief that back out to the teams when that's needed the most. So I think there's a change in that as well to explain and educate to our excavation teams. That's just that type of thing.
Yeah, so finding a better way to communicate that information to the teams on the ground would be a big win in your
Massively, yeah.
Good.
Yeah.
Okay.
Yeah, we had a utility strike recently that could have been completely avoided had these guys been trained up on the knowledge of what PAS 128 was, i.e. knowing what a B4 line is, that it's not exactly where it says it's going to be, looking for detection points on the ground, i.e. level C reconnaissance, like there's scars in the road, when they were digging above a known scar. All of that, if that had been trained out to them, they would have gone, oh, it's a known scar where we can't dig above that, there's something down there, we won't do that, we need to find a better place to start digging. But they're not furnished with that information, and I think that's critical to give these guys a chance to understand what it's all about. And it's a simple way of doing it, definitely.
Excellent. Thanks very much for that, Paul.
No problem. Thanks for letting me input.
Okay, Stuart, what other questions have we got coming in from the rest of the team?
I think we've been through the majority of the questions now. One, I mean, I'm going to ask everybody what the takeaways are from the webinar. I'm going to do that when we get closer to the end. But let me ask the audience, what are you going to take away from today's session? Because I mean, I'm fairly well versed in this, and I've learned an awful lot from what Jeff's presented and what the panelists have said already. But let's have a few more questions, if you may. There was a few people itching to ask some questions earlier.
Yeah, bring those in. I've got sort of one for, I suppose for Richard. Looking at some of the sort of the future, the technology, the kind of things that you might want to see being deployed to help you convey the information that you are providing on the line search world. What kind of things do you think would help you improve that?
Good question. I think the first thing is to understand who we're sharing that with. And we deal with up to 15,000 searches every day. So that's a search more often than you blink. And that's with the widest possible stakeholder group. And I think when listening to the opinions have been brilliant today, but in my head, I've been thinking about a standard contractor. Every time I've just been thinking about a guy in a high-vis top, thinking about with his hard hat and getting his instruction through a work permit system and all that sort of stuff. But actually, people that are at risk from striking the ground is anyone putting a spade in the ground. And so we have to be very conscious that we've got assets we need to protect. And yes, it's a shared responsibility. You know, that's where the Common Ground Alliance came from in the States. Is that there's a balance and a joint collaborative responsibility between the asset owners and the users. But it's about making something available to everyone, and Dean mentioned that earlier. So I think anything that we can do to share the information in the right possible way with the widest possible audience is what's needed. But how do we know who that right audience is? Because we know who's searching, because we can tell you that. We can tell you that all the stats and statistics, you know, all the places where they're searching, the reason why they're doing it. But who's doing the digging every day and who's causing the strikes? And that is by understanding strike data. And that's just coming back to something that Jeff was saying on his takeaways, was if you don't understand the data, if you don't collect it and if you don't analyze it properly, so it's not just getting a high level takeaway from one of the bits of it, but it's properly understanding. Because if you don't know that, you don't know what technology you need, to be honest. And that to me is where we're not going far enough at the moment in the UK. We're making some really important steps, and there's different groups doing loads of really good things, but we're not quite together at the moment where we can't say this is how many strikes are in the UK and these are the technological advances that we need. So probably not quite answering your question, but I think I'd always be of the view that engagement and getting to as many people as possible is important. Getting that information to people in whichever way you can is important, but that communication and engagement is key.
Yeah, certainly just being able to understand what is written in front of you and being able to interpret that and put it on the ground almost overlay it on the ground in your own mind before you start digging, before you start doing any sort of work, massively important, and probably we haven't really laid that down properly yet.
Yeah, I mean, I couldn't agree with you more. And there's things that we look at, and we look at a plan and go, oh, there's the line. We know where it is, and we know that it's a bit uncertain. And that was referred to earlier about knowing the limitations of that. But even just something small, we put some technology called Recite Me on our website, which is to help people with disabilities and whatever. And it's been used in anger over 700 times a month. And so the people doing the searches, we didn't even know that was a problem. And those people were struggling to get the information they need just to use the website. And it's a simple website to use. But so I think it's just understanding who the audience is massively important. So there we are. There's a technology for you that half answers your question, perhaps.
Indeed.
Thanks, Richard.
There's a couple more questions coming. One of them actually touches on, this is from Miroslav, it touches on what Paul said earlier, PAS 128. There's a big number of people in the industry who don't know what PAS 128 and PAS 256 is, including the companies who lay the services in the first place on major projects. Obviously needs education and good flow of information. Formal training should be required, the same as with the Captain Jenny stuff that we all did in the past. Once this is achieved, it will be much easier to gather all the good quality of as-built and investigation findings for future use. Couldn't agree more. Couldn't agree more. Could PAS 128 256 be included under service avoidance training and included under company policy as a minimum requirement? I would say yes. Anybody got any thoughts on that?
I think the point that Paul raised in terms of understanding that sort of translating the PAS terminology to the site teams, if they're receiving information, I think is absolutely a great point that does need to be understood at the end of the day. I mean, let's not forget, of course, that we are, even though we may not understand what PAS 128 is or indeed 256 is, we do Captain Jenny survey, we do reconnaissance work, we do record as-built and this, that and the other. So we are actually doing without necessarily understanding the requirements of the PASs. We're not going out there totally blind. We are actually doing some good work, people. The fact that we're not doing it in accordance with the PAS, don't forget that's, unless of course it's been stipulated within the contract, because PAS is a publicly available specification. It's not a British standard. It's not a mandatory requirement. It's something that's out there that we should be using and taking on board. So there's a lot of good stuff, because we as an organisation, we're involved with PAS 128 and 256 in terms of feeding back to that. So they are key documents. Do we all need to work to it? Maybe we should, but who's going to mandate that we should do that?
So I've got a controversial question, I suppose, on that front. And we found this with the BIM and digital standards, is that it's not necessarily the contractors and the consultants, etc., that are mandating these standards. It's that the client needs to say in the contract, you must do something to this standard. Do you think, I'm open to the panel, that if the client said you must follow PAS 128, 256 when laying the utilities in this project, do you think that would change that culture? Yes, of course, the contractor would put more money into the price because it's going to cost more potentially to record things to that standard. But do you think that would, that sort of mandate from a client would help, or would that hinder? I suppose, Steve, really probably is a question for yourself, being the contractor in the middle.
Basically, if it's in the contract, we know we've got to do it. We know we've got a price for it. We will do it. So it is there, and indeed, certain clients and contracts that we've got do stipulate that. My only sort of kickback would be, okay, the client may be a specific asset owner, but what happens with all the other information that we produce that doesn't deal with their particular asset?
Yeah, I suppose the information where you've discovered some other buried service whilst you're in that environment. How do you record that, and what does that information? Who does that information go to? Because you might not necessarily know who actually owns that pipe, whatever it is in the ground.
Absolutely.
I suppose that comes.
Can I kick in on that one? So on HST we use something called Photogrammetry, which is basically recording an excavation. We use it initially for trial holes, and it's just using an iPhone or a tablet device to take overlapping photographs, and from that you can make a 3D model from it using a bit of software called Context Capture. The other ones are available on the market, by the way. But that bit of technology really allows us to capture everything within that excavation, including the bit of pipe that we've laid, but all the other utilities as well. And the good thing about that is we can go back and we can model that up. We've used to 3D model all this stuff up as well. And if you don't know what that utility is, you can show it to other people who may know and say, do you know what that is? And they can say, yeah, that's an old cast iron pipe. That's for this. So it's got a load of uses. It's actually quicker process than actually a traditional survey with a GPS or a total station, because you can capture those photos in about 10 minutes.
So when you discover that,
it may take 3 times as long, maybe longer.
Yeah. So when you discover that buried service and you don't know whose it is, or you do eventually find out whose it is, who do you report that to? Because obviously that information is kept in the project. You know it's there. You've got it recorded in all your models and your drawings and the photogrammetry. But who do you report it to? Who do you give that information to so others could use that in the future?
Yeah. So that data, again, it's one of these things where it's just stored on our database. That data would get back to our client, but not necessarily out to anyone else. But that's where NUAR will kick in, because NUAR will allow you to actually do that. There's a feature within NUAR where if you find uncharted services or find a service that you wasn't aware of, you can report that back to the utility company and they can update that. So
that's voluntary.
Quite yet, but the NUAR will help assist that. Not only that, all of the surveys that we're picking up are all at a level A PAS level, all picked up via either total station or GPS or photogrammetry, so they're millimetre perfect. But when that data will go back out to our back to our utility clients, it'll go back out at level D, which I find crazy. We've made all that effort to capture that data using a total station with a survey report, and it'll go back out at a level D.
Yeah,
which is a real disappointment.
Could I just pop in on that one? Because we're very conscious. We send out, up to 100,000, maybe more responses per utility every month for the larger ones. So that's 100,000 times someone's received their plans and been able to do some work. And the number of people coming back is minimal. And we've launched a trial, an off-gem back trial for UK Power Networks, so that anyone receive, and that's for them it would be probably 4,000 or 5,000 people every day get their plans. They've got a free, really simple upload facility to allow someone to send back information of when their plans are accurate or when they might not be as accurate as desired, and that's available for everyone now. And I think what we're finding is that people aren't using that enough. I'll be quite honest, and I think what the critical thing is not just providing the technology, but actually understanding the environment those people work in, and do they have the incentive to send that back? Do they have the time? Do they have the knowledge? Have they has that reasoning been communicated to them? That, to me, and I'm nothing but if not predictable. That's why I think the technology is a secondary thing, because that facility exists and that is available now. It's going out as we speak. But the responses aren't coming back as much as you would hope. So
yeah, I would completely agree with you, Richard, there, because we know in industry that actually nothing happens unless you're either paid to do it or you'll go to jail if you don't do it. And if we don't have strong legislation in place to actually get people to put that information into that central repository, then it's not going to happen.
And I think
or for it to happen.
Exactly, and I think from Jeff's example, the French example to me is the most interesting for us as an industry, where you've got the government has intervened to encourage behaviour. So they've intervened on the outputs. They haven't got into the nitty gritty and saying that we're going to do something that you all have to do. They've said, but I understand, Jeff, from your slide and from the presentation on your webinar, was actually you're now empowered and you're now responsible for making sure that accuracy is there. And not only that, you've got to report the damages. So to me, from a legislation perspective, from a mandatory perspective, getting that damage reporting as mandatory would be amazing, and having a sort of an incentive for the asset owners to improve the accuracy of the data to make it valuable to them. To me, that would be very helpful.
I wonder whether, it's probably a question for Steve in here as well, is the contingency pot you have to put in place for each project to cover utility strike, whether that insurance cost, that contingency pot, whatever it might be, if the risk is reduced dramatically because of that sort of legislation in place or whatever it might be, do you think that might change the dynamic there, or do you think that's probably a step too far?
Well, if I could jump in on that one, I've talked to a large insurance company in Chicago, AXA. They're one of the largest construction insurance companies. And I asked them, I said, well, how much would a mom and pop construction contractor pay in insurance? And he said, well, if their revenue was like $25 to $40 million annually, I mean, this is small potatoes, right, for a contractor. The other thing, that they would probably pay about $1 million in insurance, right? And in North America, this is a low margin business. Contracting is a low margin business, especially for the mom and pop shops, right? So even if you could knock a few percentage points off the insurance, that could be a real benefit for the contractors.
Yeah. Any thoughts on that one, Steve? Do you think that might be a...
Yeah, I mean, it's another big topic, Ian, to be honest. It's not just, let's not forget, this is not just about cost.
No.
This is about saving lives. This is safety. It's driven by safety at the end of the day. We have certainly, within my organisation, it's a fatal risk group that looks at utility strikes. It's fatal risk. So we do not want that to happen at all. However, if there is a strike, and we do have strikes, we are looking at trying to be as safe as possible, yes. Trying to make sure that we do the job right first time, because by hitting something, it delays us. It's a program issue. There's the direct costs, and in the previous example that Jeff made in his first commit presentation, they referenced the direct and indirect costs related to a strike. Now, if we do have a strike, it costs us, my organisation, but also there are other indirect costs associated with customers, with road users, with everything else there. And also as well, let's not forget the fact that by actually doing extra work, extra activity, extra reinstatement, extra backfill, what's our carbon footprint going to look like?
Yeah.
So that's another driver. Safety, driving our carbon footprint down, saving costs, all that is all part of what we need to do. Yes, we do have insurance, but you can't rely upon that. That's not going to get you out of jail just because you've got insurance.
No, very true. Very good point, Steve. So, Stuart, what other questions have we got coming in from the audience?
Andrew asks, how many service companies have ever been prosecuted for evidence of poor service installation by tracking back incident investigations?
Wow.
Not sure on the answer to that one. Anybody know the answer to that?
No. Well, I think very low number.
Yeah.
To be honest. There'd be lots of examples where there've been assets have been struck that they're not in accordance with this, that, and the other. There's no. I'm just off the top of my head. I don't think there's been any major prosecutions in that respect, to be honest.
The only thing that I can draw a parallel with is I saw it today actually, where there was a drainage system that Carillion had been involved with in the Stonehaven rail crash.
Yes.
So that does draw a similar parallel of faulty installation of a drainage ditch that led to a rail crash, and there were but I don't know the answer to the question, but it seems a fairly clear parallel.
Yeah. Okay, guys, I'm conscious of time. There's a few thank yous to do, but any more questions from you, Ian?
No, I think we're good.
Can I just go around the room and just very briefly ask for the main takeaways from today? I'm going to go to Scotty first. Scotty, from your position in Reconstruct, you're looking at 4D and digital twins. There's a lot to offer. We talked about technology and what technology can do for the industry. It's doing a lot everywhere else. I mean, if you look at some of the things that are on construction projects now, it's phenomenal what's actually taking place. And I'd like to think the same thing could happen, with identifying and uncovering underground apparatus. So, Scotty, give me your take on today, this webinar, what people can expect.
Yeah, I'm hearing something that I hear often when it comes to reality capture, reality model, digital twin technology, which is that it could be a big help, but we're still in an early adoption phase, and a lot of the behavioral drivers, the regulatory drivers, or just the base understanding of the technology by the folks on the ground is not here yet. So my main takeaway is to continue working on a lot of the educational content that I can contribute and Reconstruct can contribute to drive that understanding for the operators who are in the field, so that we're ready. They have understanding as the drivers come up to par.
Okay, thank you. Jeff, I'm going to come to you next. You're in line. Just the parting shots.
Yeah, I think there's two things I'd like to mention. Again, no silver bullet. That this really requires the cooperation between all the stakeholders, contractors, network operators, government agencies, located industry, and so on. And the second thing is, it's really hard to make an assessment of what you're doing if you don't have data. And I agree totally with Richard. If we don't have data on underground strikes, and we can't track how that changes over time, it's very difficult to tell whether anything you're doing is effective or not.
Sure. Going to go to Dean next.
Yeah, I think it's quite clear that I need to work a bit more closely with my geomatics colleagues within Leica to do some more reality capture in relation to service mapping as well as avoidance. I think at the moment we're just scratching the surface with it. Having listened to what you guys are saying, it's quite apparent that there's a hunger for these technologies to join, not just for above ground assets, but also for below ground. And the other thing I'll take away from it is I think I might need to expand the slide on the PAS 128 on my training courses by the sounds of this. So, I'll get on that over the weekend.
We're really positive. Thank you, Dean.
Thank you.
Steve, can I come to you next?
Yeah, okay. Right, I've got quite a few takeaways near us, so let me just go through three of them, to be honest. Just taking heed of sort of Jeff's well-made points, quite absolutely brilliant to have an overview of what's happening around the world in some ways. And thanks for that, Jeff, for all those points. But I'd like to consider that there are possibly different ones for me, for the different stakeholders that I'm involved with. I'd just like to quickly go through them. One of them is obviously in terms of my own organisation, is to recognise across all our various types of projects, we are genuinely trying to do the best and as safe a job as we can, but we can't necessarily resolve the problem of utility strikes on our own. Some of our projects want to work away from the services, but there are others that want to work on them, which are generally located in the most difficult and congested areas we have. So that's footpaths and roads. So by being able to plan the work properly, visualize it with all the new technology and everything else out there that Jeff summarised, and understand the hazards better before breaking ground is absolutely essential for us. So as I mentioned before, we need to be safer, better, leaner and faster. And by doing so, we will be greener. And that's a big area that comes through.
Indeed.
Also as well, in terms of USAG, the Utility Strike Avoidance Group, and the recognition that as an organisation, it needs to continue to be actively involved and share knowledge and experience of their members with the wider industry, including the ongoing NUR team, and somehow be able to influence their final delivery outcome. Not ignoring the homeowner, these are words that Richard comes out with, not ignoring the homeowner, the farmer and the developer and others, because USAG are committed to reducing strikes for all involved in excavations, not just the contractors out there that we see, but there are others that dig, which includes homeowners, farmers and other development type activities. And also as well, I'd just like to mention in terms of CECA, the Civil Engineering Contracts Association, I'm supporting the development of their sort of safe digging initiative that's going to happen this year, and to share them the message that this is not an easy issue to resolve. Many stakeholders, and we mentioned some of them before, the asset owners, designers are included in all this, contractors, supply chain partners, train providers, plus many, many more are involved and need to collaborate together to forge a key to unlock a safe, accessible and sustainable solution, which will enable better surveying, designing and planning, ultimately supporting safer digging. Because safe digging is the product of adequate and sufficient experience, resources, and importantly, time. So with the right tools, the right team, the right information and right behaviours, because I think there's a lot of behavioural issues that we need to address, and these will form that elusive silver bullet.
Brilliant.
Just jotted those notes down, to be honest.
Well, thanks, Steve. That was quite comprehensive. I'm going to come to Richard now. Richard, do you want to give us your parting shots?
Yeah, I'm going to have three. I'm going to be as quick as I can. Firstly, understand the problem, understand the data, get the data shared, or get the data collated, shared, and understood. Understand the people. So that's number two. Understand the data, number one. Understand the people, number two. And that is that safe digging is for all. We've got to understand who's out there, who's doing all the work around those assets. And then number three is understand the solutions. Sure. And that's where all the cool stuff that Jeff's been looking at is all, you know, they are all brilliant things to do. But if we don't know those previous two, then when those bullets aren't going to hit. Yeah.
Well, as I said at the beginning, there is a solution amongst all of this. Before I do any further, I'm just going to ask Ian if he's got any parting shots from the webinar today and the information that's been shared. Ian?
Yeah, I think, you know, you're right in the people, the culture, the technology. There are so many different strands in here that we need to start bringing together. Just the fact that we don't have that real common way of reporting yet, the fact that things aren't mandated yet, the things that there isn't a financial incentive in the process yet, I think are all issues that we need to come over. But I think there's a will. I see so much positivity in this that we're going to get something done. We will drive forward. You've got a great team, you know, assembled in front of you, Stuart. I think, you know, we've got a good opportunity to do something.
We have indeed. And just for clarity, I mentioned safety at the beginning. When I was actively working in operations, the first thing we did was make sure that we didn't do any work without it being safe. So if there was any risk, we'd put more measures in place. Uncharted services were something we found many times every day, but we had to have a safe system of work, otherwise we didn't progress. And that was end of. It just didn't go any further. And I know you guys all practice that, but I think today has been a great session. I'd like to thank Jeff for many months of planning this. We started talking about it sort of midway through last year, and we talked about how we would do it. We'd sort of build on the success of the one we did 19 months ago. Thanks to Steve, your input Thanks to Scotty, Richard, Dean. And I'd like to also thank Jerry for your support as well, for making these webinars happen, as I say every time. I'll also like to wish everybody a great weekend. And I'm sorry I can't show you the rest of the slides. Somewhere in the process, the slides froze. So we're stuck on the question time slide. But there is another webinar in 1 month's time. And it's even been suggested already today that we should do this webinar once again in 6 months' time, because people are absolutely convinced that the developments will be sufficient that we could share once again. So if everybody's up for that, then let's look at doing it again in 6 months' time. And yeah, so have a great weekend, everybody. Thanks to all the panelists. Thanks for all the questions. Thanks for everybody getting involved. Thank you, and have a great weekend. All the best.
Well done. Well done. Bye, everyone. Have a nice weekend.
Thank you.
Bye.
Bye.
Brilliant. Fantastic.
Thanks, everybody.